So picture this. You're right in the middle of a project. You grab your multimeter for that one crucial reading, and you get nothing. Dead silence. It's got to be one of the most frustrating moments, right? But don't worry, we're about to crack this case wide open.
We've all been there. One minute, it's your most reliable tool, and the next, it's basically a paperweight. But you know what? The solution is usually way, way simpler than you think. You just gotta know where to look.
So that's what we're going to do. We're going to put on our detective hats and walk through a really simple diagnostic process. We're going to hunt down the 3 most frequent culprits that cause a multimeter to fail and turn this whole frustrating problem into a super quick fix.
Okay, first up on our suspect list, and honestly, this is the most common offender by a long shot, is the power source itself, the battery. I know, it sounds almost too simple, but you would be shocked at how often this is the root of the entire problem.
Seriously, before your mind starts racing and imagining some kind of catastrophic internal failure, the battery should always be the very first thing you check. If the meter won't power on at all, or if it's acting weird and giving you unreliable readings, it's probably just starving for power.
And just look at the difference here. A weak, dying battery might still show some voltage, maybe, a quarter of a volt, but that is nowhere near enough juice. A brand new 9-volt battery, on the other hand, will actually read a little bit higher than 9 volts, something like 9.6. That's the number you're looking for.
All right, so you've checked the battery, and it's good to go. Now we move on to our second suspect, the test leads. If your meter has power but you just can't get it to read anything, then these lines of communication are exactly where we need to focus our investigation.
So this is a really specific clue. Your screen lights up just fine, you can see all the digits, but when you actually touch the probes to a circuit, crickets. Nothing happens. That symptom points the finger directly at a problem with your test leads.
So how do we interrogate these leads? It's a simple 3-step process. First, just give them a good look, a visual inspection. Do you see any obvious burns or cuts or really sharp kinks in the wire? Second, you're going to perform a continuity test using a multimeter you know is working. And third, while you're doing that test, you do the wiggle test. This is key for finding those sneaky hidden breaks inside the wire.
Now that continuity test is just checking for a solid, unbroken path for electricity to flow through the lead. So if the screen on your good meter flashes OL, that's your smoking gun. It stands for out of limits or open line. Basically, it's telling you the path is broken. There's a gap somewhere in that wire.
And this is exactly where that wiggle test becomes the hero. As you're checking for continuity, gently bend and flex the wire, especially near the connectors. If you hear that beep start and stop as you move it around, bingo, you've found an internal break. The wire is shot, and it's time to get a new set of leads.
All right, for our third and final suspect, we've got to go inside the meter itself. We're looking for the internal guardian, the little component that protects all the sensitive circuits, the fuse.
Now this suspect has a very specific MO. Your multimeter is working just fine for checking voltage, and it's perfect for resistance, but the second you switch it over to measure current, amps or milliamps, you get absolutely nothing. See, it's not a total failure, it's a very targeted one.
And here's why that happens. The internal fuses are there for one reason, to protect the very sensitive circuits that measure current. So if you accidentally try to measure too much current, the fuse acts like a bodyguard. It sacrifices itself to save the rest of the meter. And yeah, most professional-grade meters actually have 2 of them for different current ranges.
Checking the fuses is pretty straightforward, but you have to be safe, okay? Step 1, and this is non-negotiable, is to make sure the multimeter you're fixing is powered completely off. Once you're sure it's off, you can use your working meter, set it to continuity or resistance, and test each fuse just like we tested the leads.
The result here is totally black and white. A good fuse will give you that nice continuity beep and show a super low resistance. A blown fuse, well, it'll show OL, that open line, and stay completely silent. If it's blown, that just means it did its job perfectly. Now, you just have to replace it with a new one that has the exact same rating.
And just like that, case closed. We've investigated our 3 main suspects, and now you have a clear, simple game plan for the next time your multimeter decides to act up.
So let's lock this in as a quick mental checklist. If your meter is completely dead, won't turn on, check the battery first. If it turns on but gives you 0 or crazy readings, test your leads. And if it only fails when you try to measure current, time to inspect those internal fuses. It really is that simple most of the time.
You know, by mastering this little bit of troubleshooting, you didn't just save your tool, you also sharpened your own diagnostic skills. This whole logical process, eliminating suspects one by one, is the key to solving pretty much any technical problem out there. So the only question left is, what are you going to fix next?